Let's consider the problem of computing the Karl Pearson's coefficient of skewness for a continuous series. The Karl Pearson's coefficient of skewness is denoted as SKP, and it is computed as mean minus mode divided by sigma. This is a continuous series, so for mean the formula is summation Fm by summation F. For standard deviation, the formula is summation Fm square by summation F minus summation Fm by summation F the whole square. And for mode, the formula is L plus del 1 by del 1 plus del 2 into I. So, these are the requirements. Let us form the tables. Let us write the class intervals in the first column: 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. The frequencies are 14, 21, 28, 34, 27, 26 and 20. Let us compute the midpoints. 20 plus 30 divided by 2, 30 plus 40 divided by 2, the midpoints Fm values, multiply the corresponding values. (26 into 75). 20 into 85. So when I add all these values, you get 9620, and the sum of F values are 170. And with this the mean can be computed, and to compute this sigma, let us have a column Fm square, Fm into m. You should multiply the corresponding values of Fm and m. Multiply these two. Multiply these two, 55 and 1870. Multiply 65 and 17755. 75 and 1950. 85 and 1700. And here the total is 59. 5,98,850. Okay, So let us compute mean, that is x bar, summation fm by summation f, 9620 divided by summation f is 170, 56.59. Let us compute standard deviation. Summation fm square by summation f minus summation fm by summation f the whole square, square root of 5,98,850 divided by 170 minus 9620 divided by 170 the whole square. The answer is 17.90. Now to compute mode, let us frame the grouping table. The class intervals are 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80 and 80 to 90. The frequencies have it as the first column 14, 21, 28, 34, 27, 26, 20. In the second column, let us group the values in twos. Only one value is there, leave it. In the third column, leave the first value and group in twos. Okay. In the fourth column, group in threes from the top. Group in threes. In the fifth column, leave the first value and group in threes. In the sixth column, leave the first two values and group in threes. Highlight the maximum value in each column. Let us form the analysis table. Class interval in the topmost row. Column numbers in the leftmost column. In the first column, maximum value is 34. It corresponds to 50 to 60. So against 50 to 60, I put a tally. In the second column, maximum value is 62. You got it by adding these two numbers. So 40 to 50 and 50 to 60. Put tally marks. In the next column, it is 61. You got it by adding these two numbers. So 50 to 60 and 60 to 70. In the next column, it is 87. You got it by adding these three numbers. 50 to 60, 60 to 70, 70 to 80. In the next column, that is in the fifth column, the maximum value is 83. You got it by adding these three numbers. 30 to 40, 40 to 50, 50 to 60. In the next column, it is 89. You got it by adding these three numbers. 40 to 50, 50 to 60, 60 to 70. The total is 1, 3, 6, 3, 1. Fine. So you got 50 to 60 as the model class. Let us write 50 to 60 is the model class. The lower limit of the modal class is 50, right? F naught, the frequency of pre-modal class is 28. The frequency of the modal class is 34. The frequency of the post-modal class is 27. Delta 1 is modulus of F1 minus F naught, that is modulus of 34 minus 28. 6. Delta 2 is modulus of F1 minus F2, that is 34 minus 27, which is equal to 7. I is the magnitude of the class interval 10. So mode is L plus delta 1 by delta 1 plus delta 2 into I. 50 plus 6 by 6 plus 7 into I is 10. Your answer is 54.62. Okay, for mode it is 54.62. Now let us compute the Karl Pearson coefficient of skewness, which is mean minus mode divided by sigma. Your mean, we computed the mean as 56.59 and standard deviation as 17.90. Let us use those values here. Mean is 56.59, mode is 54.62, standard deviation is 17.9. Okay, 56.59 divided by 54.62 divided by 17.9. You get 0.11, a positive value. So you come to the conclusion that the distribution is positively skewed. So this is how you compute the Karl Pearson's coefficient of skewness for a continuous series. First, mean and standard deviation should be computed. Then you identify the modal value. Okay. Thank you.